Today we're going to talk about inverses and transposes, and we're going to do that by going through an example. So I've written out some of the properties of the matrix inverse and the transpose and how they kind of interact with each other. So the first property I've written here, A times A inverse is I, and equivalently, A inverse times A is equal to I, where I is the identity matrix. This is kind of the definition of an inverse. If A is invertible, then if I multiply A by its inverse, I should get the identity. The second property I've written here is that A inverse inverse equals A. What this is saying is that the inverse of A inverse is A itself. And you can kind of think of that as the opposite, not really the opposite, but like the equivalent of this. If you think about A inverse as the matrix you're interested in, the inverse of that is this matrix that you multiply by to get the identity. So it's kind of just saying that the inverse undoes itself, basically. The third property says that if you take the inverse of a product, you can, that's going to be equal to the product of the inverses, but you have to switch their order. So remember that matrix multiplication is not commutative, meaning that in general, A, B, maybe I'll write it like this, AB is not equal to B times A in general. You can think of some specific examples, but this doesn't hold in general. So that's why it's important when you look at this type of property that the order of this multiplication does matter. All right, so the inverse of the product, A times B, is equal to B inverse times A inverse in that order. A similar thing can be said about the transpose. So if you take the transpose of a product, that's equal to the transpose of the matrix on the right times the transpose of the matrix that was on the left. So the transpose of A times B is equal to B transpose and then times A transpose in that order. All right, and the last property we're going to be concerned with today is that you can kind of swap the inverse and the transpose. So the transpose of A inverse is the inverse of A transpose. Okay, so another way of thinking about this as a side note here is that the inverse of A transpose, meaning if I had A transpose and I wanted to know what the inverse of that was, that's this matrix here, that's actually equal to, this matrix here is equal to A inverse transpose. So you can kind of think of this as you're able to swap that transpose and inverse. Okay, that's how we'll use it anyways for this example. All right, so the example we're going to deal with today is which of the following is equivalent to this quantity here. So A transpose times B inverse A inverse transpose, and then all of that inverse. So which of these quantities is equal to that? So we're just going to do some manipulation with these properties up here and try to answer this question. So I'm going to go to the next page here. I've copied down the properties here on the left, so we have those to reference, and I've written down the quantity we're trying to compute. All right, so let's get started here. So first, I'm going to start with kind of what's in the parentheses in this area here. So what is this B inverse A inverse transpose? Okay, so I'm going to try to sort out what that should be. So let me get a different color here. All right. So B inverse times A inverse transpose. For this, I'm going to use this property here, this third property, that if I want to take the transpose of a product, the product in this case being B inverse times A inverse, I just need to swap the order. So this is going to be equal to A inverse transpose times B inverse transpose. So notice that I swapped the order here. So B inverse was on the left, now it's on the right. A inverse was on the right, now it's on the left. And the transpose then can get distributed. All right, so let me rewrite the original problem again. So we still have A transpose over here on the left. That's from that guy there. And now, instead of the highlighted portion, now we have inverse transpose times B inverse transpose, and then we still have the parentheses and the inverse on the outside. All right, so the next thing I'm going to do is try to take care of this, this product here. So notice that, let me maybe get a different color highlighter. This quantity here is going to allow us to use this last property. So let me get another color here. This last property here, that we can swap the inverse and the transpose. So A inverse transpose, this is equal to A transpose inverse. Okay. So let me go ahead and write out what we have now. We still have A transpose on the left. Now instead of A inverse transpose, we've got A transpose inverse. And then we still have that term B inverse transpose. And then all of that has an inverse on the outside. Okay. Now, this couple here, this product, is actually giving us this first property here. We have a matrix, A transpose, times its inverse, A transpose inverse. That's going to give us the identity. Okay, so I'm focusing on this product here. And I'll just write this in green so that it matches. This is actually equal to the identity because it is a matrix times its own inverse. Okay, and when you think about the identity of a matrix, it's kind of like the matrix equivalent of the number 1 when you're thinking about multiplying. So another way to think about that is that this kind of like cancels each other out. Okay, so that's one way to think about that. All right. All right, so what are we left with? Well, the identity here is kind of like multiplying by 1 for a matrix. So we actually don't need to write this again. It's just kind of the same way you would leave out multiplying by 1. And what we have left is now basically the identity times B inverse transpose, and then we still have that inverse on the outside here. So this is still, let me make this the appropriate color, this is still that orange term that we have up here. So same term. All right, so once again, I'm going to use, let me just highlight here that this term, this thing that we did here with the identity, that was this first property. And now I'm going to focus on this term here inside the parentheses. So let me get a different color here. This inside the parentheses, I can again swap the transpose and the inverse. So that's this last property again. I'm going to apply that again here, but this time to the matrix B. So now I've got B transpose inverse on the inside. I still have that inverse on the outside. So finally, I'm going to use this property up here that the inverse of the inverse is the original matrix. And the reason I'm using that is because I have an inverse of an inverse here. Okay, so this is equal to just the matrix that's left inside there. So these kind of cancel each other out, and I just get B transpose. And that's going to be my final answer. So if we scroll back up here, B transpose is choice A. Now, so now we just saw that this whole product, this whole kind of complicated mess, is equal to just B transpose. So I'll scroll down again so you can see how we found that, that quantity. And hopefully that answers any questions you had about how the transpose and the inverse kind of interact with each other. Let me know if you have any further questions.